but we're going to move on to session 4 of the conference, and it's our first panel session for today. And this is all focused on getting aircraft ready for hydrogen. And we couldn't really have a better moderator for this panel in the shape of Graham Warwick, Managing Editor of Technology at Aviation Week. Graham has 40 years of aviation journalism experience, and we'd like to have him with us today. So Graham, please take it away.
All right. Okay. So thank you very much, folks. So again, I am Graham Warwick. I'm the technology editor for Aviation Week. As we heard on the first day of this conference, there is a lot going on this week about hydrogen in aviation. But while the major aerospace companies are spending a lot of their own and their government's money on technology development and demonstration, they've yet to commit to developing a product. And as Airbus CEO Guillaume Faury said just yesterday, even if they are technologically in a position to decide in 2028 to launch development of a hydrogen fuel aircraft for service entry in 2035, the hydrogen infrastructure may not be ready and the aircraft may have to be delayed towards the middle of the century. So if we want green hydrogen to play a role in the decarbonisation of aviation beyond its use in the production of sustainable aviation fuel, we need to start now and start somehow. And the place to start appears to be with smaller, shorter range regional aircraft, which are within reach of the available fuel cell technology once it is adapted and optimized for aircraft application. And Richard Moriarty, yesterday, the CEO of the UK Civil Aviation Authority, said, we need to trial some stuff. We need to learn by doing. And that's what companies like the ZeroAvia are doing, with the agility and the risk tolerance of a startup, but within the safety constraints of a company that wants to build a lasting business and also make a lasting difference. So this panel will take a closer look at how we get aircraft ready for hydrogen. So I will introduce our speakers now, beginning with Gabriele Teofili, Head of Aircraft Integration and Testing at ZeroAvia. Gabriele worked first at Leonardo Helicopter and Airbus Helicopter with chief engineer and airworthiness responsibilities. He then joined the electric aircraft development journey, first with Siemens, who were a pioneer in this industry, and then with Rolls-Royce Electrical, where he actually signed the first commercial contract with eVTOL developer Vertical Aerospace. So our second panelist is Elio Ruggi. He is the Senior Vice President and Head of Aircraft Development, Quality and Flight Controls at MHI RJ, which is the name of the company after Mitsubishi Heavy Industries bought Bombardier's CRJ division. They took over the they took over the type certificate, they took over the long-term support and future upgrades to that very popular aircraft. So previously at Bombardier for 20 years, Elio held the full type design responsibility for the CRJ, including engineering, quality, product safety, flight operations, and technical services. He also supported the entry into service of the Airbus 220, who some of us still fondly think of as the Bombardier C series. And he was also had full accountability for the revamp of the Q400 line, which was a big undertaking. Our third panelist is Derk Nieuwenhuijze. Derk is Head of Strategy, Marketing and Communication at Air France Industries KLM Engineering and Maintenance, one of the most complicated acronyms in this industry. Derk joined KLM in 2016, and he was previously Deputy Director of Component MRO, leading a team developing new technological capabilities for the Airbus A350 and Boeing 787, which I think positioned him well in his current role of helping AFI, KLM, E&M embrace these many new technologies that are coming into the market. And our final panelist is Richard Berkling. He is CEO of PowerCell Sweden, which is a leading fuel cell supplier and a partner of ZeroAvia. Richard was previously president of CPAC Systems, a subsidiary within the Volvo Group, where he built up the company, which specialized in safety critical electronics for the marine and off-highway transportation industry. So I'm going to start with you, Gabriele. Take us away.
Thank you, Graham. Thank you very much. And it's very nice to be here with this panel. It's a nice story we are building in terms of partnership between us. You mentioned the right things. We need to start with demonstrating something. And this is the best place in order to get something done. It's one of our philosophy. We don't want to speak about things. We want to do things. We want to act in order to demonstrate that the hydrogen and the fuel cell system connected with an electrical engine can work in flight, can work on ground, can work on a test lab, and can work in flight in particular. How do we do it with ZeroAvia? You mentioned my experience. I've been in quite a few corporate company where we have demonstrated together that the ambition to fly safe and to develop new system fast is possible. The ZeroAvia addition to my knowledge is the possibility, first of all, to enlarge the portfolio of electrification of aviation with hydrogen. Hydrogen is allowing us to make much a longer shot compared to other configuration. The addition of ZeroAvia spirit in this pioneering decarbonization of aviation environment is the following. We want to get something done, we do it, we make, nevertheless, development in scale, test in scale. If we look at the history of ZeroAvia in the last 4 years, we can see that we have performed step-by-step approach in a very, very fast pace in terms of testing something on ground, installing it on an aircraft with our Piper Malibu, for example, flight testing the hydrogen electric powertrain, coming back to the ground, installing a bigger kilowatt range on our Hypertruck, which is our ground test facilities in California, verifying that the assembly for the new propulsion system size works on ground, and in parallel installing on an aircraft. This aircraft that is here in my background is ready for flight. It's a CS-23 aircraft, a 19-seater aircraft, is equipped with a 600 kilowatt hydrogen electric powertrain. Yes, we are still testing the system on ground. We are still testing new technology. In the meantime, we get to become airborne based on safe steps. They are progressive. They go from low power to high power, but they are pragmatic. They give us data. They give us validation of information that only via ground laboratory and flight testing you can get. The Dornier 228 is a step towards the future. So what we do in ZeroAvia is to demonstrate that what we are speaking about works and getting the data so that we can feedback to our engineer immediately so that they can work for the next generation. We have the next generation of system for this size of aircraft and for the higher one, like 2000 kilowatts, for example, already under design and under test in our lab. We have the idea to complete the full pattern of propulsion system offered, going towards our vision, which is hydrogen electric in every aircraft, already studying the next configuration. That's why we believe strongly in partnership. The partnership we have for Textron today, developing together a system for 600 kilowatts, for example, is a great opportunity for a small company like us to play with the right players in the world of aviation. The partnership we have with MHI and the study we are doing with Elio, for example, is a demonstration that we are not targeting a show. We are not targeting a picture on the press or on the magazine. We are targeting to enter into the aviation world as protagonists and to feed every single aircraft which is flying with hydrogen electric powertrain. How do we do it for the next step? I would like very much Elio to support me and to describe it.
So handing over to you, Elio. Thank you,
Sure.
Gabriele.
Yeah, thank you, Gabriele, and good afternoon, everyone. So maybe just a little bit about MHI RJ. Thanks for the great introduction, Graham. We are the very proud type certificate holder of the CRJ. CRJ is arguably the backbone of the regional jet market in the world. We've built over 2,000 CRJs. There's still 1,300 aircraft flying today. And we have the largest MRO in North America for regional jets supporting that fleet. So very proud to to be the owners of that product, and now to be able to bring our knowledge and depth of expertise as an OEM for over 30 years to these new technologies that are being explored and being developed into this next generation. So as Gabriele described, some of those testing fundamentals are already ongoing, and we're able to add huge value, and we've already been able to demonstrate that in our collaboration with ZeroAvia, is really studying and developing and putting on paper in real terms. This is not a study, this is real OEM effort to now start to create a definition that could be brought to market, is scalable, has an industrialization thought process as a foundation, and in the end can be applied to the real world in a way that's viable for real life operations, and that's key. So the success that we've made so far continues to demonstrate that all of those aspects are achievable, and that we are together on the right roadmap to get that done.
Thank you, Elio. So folks, don't forget to put your questions in the Q&A. Otherwise, I'll be left to make the questions up, and we have no idea where that's going to lead to. So please get your questions in. So I'm going to hand over now to Derk.
Sure. Yeah. So also from an Air France KLM perspective, of course, we're very closely watching these developments. We're really trying to learn what's going on, how can we benefit from that, but also what can we contribute to the market. And I think that we as an established player are actually very excited about everything that's going on the different fields and the different markets. And we really believe that on the long term, this will have a tremendous effect on the aviation industry as well. So we, let's say, being more established, having a strong network, etc., try to leverage that in terms of logistics, in terms of training, because whatever new aircraft comes out on top, and I hope it will be multiple new OEMs that we will be able to work with, they will need a lot of support around it. So coming from the maintenance side, we are already looking into, okay, how do you maintain such an aircraft? What kind of logistics does it need in terms of parts and support? What kind of training do you need for all the different checks that you will have to warranty the safety and the flight safety? So those are really things that we're all looking into. And I think a final element that will be extremely interesting is that this, of course, everything that we're adding or changing to that aircraft will be much more modern than any of the previous ones. So there will be more sensors, more knowledge, more data in these aircraft than ever before. And what we're already seeing in the platforms of the 787, A350 that will continue, that you have such smart aircraft that you, with predictive maintenance and a lot of the tools that you can develop around that, you can actually really drive and steer also the cost of such an aircraft further down. So we're really actively working like with different of these parties to try to lower those costs and to create solutions that work for OEMs and for airlines that come after that.
Thank you, Derk. Yes, supporting these new technologies is going to be critical. So, and I'll just introduce our last panelist, who I think is going to introduce somebody himself. Over to you, Richard, on the fuel cell side.
Thank you very much. I'm joined here also by Carl Samuelsson for some expertise into the matter, not just me talking. Really encouraging to be part of this panel and also listening in, not just to Val, but also Jill from American Airlines, showing a lot of determination to do this. And I think this is what is attracting us to work so closely with ZeroAvia, because it requires leadership to be a pioneer in a technology shift. And we talk a lot about risk, but it's also about mitigating risk and bringing industrialized solutions to the market while still working on the next generation and the generation after that one. And we see that in the collaboration with ZeroAvia. So us being one of the leaders in fuel cell technology, having industrialized core components, working so closely with ZeroAvia and contributing to their testing, I think together we can bring a technology to the market that is accelerating the decarbonization of a really hard to abate industry, And for PowerCell, working with companies like ZeroAvia and others is really challenging our technology and our industrialization of core technology. So it is a really, really good combination. So although it is still a lot of exploration going on, together with ZeroAvia, we signed the first commercial agreement in this industry, in the fuel cell industry in general. And I have to admit that a year ago, if somebody asked me if it would have been aviation to be the kind of the spearhead into commercializing fuel cell technology in electrification, I think I would have laughed. But as we see how fast this is progressing, and the entrepreneurial spirit of ZeroAvia and the industry, I'm really happy to be part of this, and also hopefully can contribute both in this panel today, but especially into the market introduction of new technology.
Thank you, Richard. So, I wanted to turn back to you, Gabriele. So, a couple of years ago, you were flying the Malibu, and you seemed to still be learning how to operate a fuel cell in flight, what levers you could pull to optimize the operation. A couple of years from now, you kind of want to have a system on the market. You're sitting there ready to fly the 228. How mature is this technology? Is it really ready to go into not just aviation, but commercial aviation that has expectations for performance, reliability, safety? How ready is it?
So what I have learned in my career is that if you become airborne with a platform, a demonstrator, for example, you learn a lot of things. Learning is a long process. It can come through success, which is normally what is presented online. It can come through failure, which is also sometimes presented online. I cannot forget the tweet of Elon Musk about the explosion of all the rockets of the SpaceX before getting the rocket landing on the platform. That was not a failure, that was a learning moment. And when you don't have failure anymore or improvement anymore, you finish the learning. It's a sad moment for the engineers. And what we are doing today is placing on a bigger aircraft a scaled version of our hydrogen electric powertrain to understand what we have not learned yet on every other possible test lab. So we have different test rigs. So it can be a single fuel cell with a single thermal management, a small compressor. It can be an electrical motor test rig with a propeller load or pretending to have to be a propeller. We know which part of the system have a maturity which has to accelerate. We have to discover what we have not discovered yet because we didn't become airborne. Even the capability of people to think safety, to think to send a fuel cell producing electricity on the air with such a scale of aircraft, which never happened before, it's an incredible moment to understand, are we mature enough, not the technology. The technology is challenging. There are particular points where you cannot be sure about how much the functioning of the system and work is safe enough. There is no risk to send this aircraft to the sky. There is a risk that we don't learn enough if we are not fast enough. So one of the points, in order to answer your questions, we have a map of components of the powertrain where we know we have to accelerate the maturity of the technology. How do you do it? By testing. How do you do it? By retrofitting or feedbacking companies like PowerCell, for example, with information from different type of learnings, even from a very, very small scale test. So the aircraft and flying the aircraft will bring us a full map of understanding. When you have the understanding, it's just a matter of work and a matter of making an effort. We will not wait for the technology to mature itself if you don't put an effort and you accelerate the points which are the new in the world of aviation.
So Elio, how do you feel about this? I mean, you have the responsibility to your customers to if you go down this route, you have to deliver a commercially viable, reliable, safe product into into a market that has very thin margins today and needs a good product to keep having thin margins while they also become more sustainable. So how do you feel about the maturity, the roadmap, the work that is being done? Does it make you feel, do you have a level of comfort about where we're going?
Well, I think the polarity of that is actually very complementary. So what Gabriele describes to you is the discovery and the blind spots of when you're trying to do something as industry leading as ZeroAvia is trying to do today. So it's understood that when you're trying to distinguish yourself from the herd, you're trying to go into a part of the envelope that nobody's ever been before. It will come with question marks and some trial and error. Where our collaboration really becomes a match made in heaven is that now you apply that to a product like the CRJ, who has a ton of maturity, a ton of predictability. We have over 54 million hours of in-service operation. So we become a benchmark reference, a baseline that you can depend on. And so combining that with the new technology really becomes favorable, because now you really limit the element of discovery to the new portion of the system, the fuel cell, the hydrogen tanks, the integration, the installation. But you're working with a team that has an aircraft definition that is so predictable, it helps to leapfrog the work that needs to get done. So you're asking me how I feel about this. I'm very comfortable with the work that needs to be done, and combined with the steady hand of our expertise and the maturity of our platform, I think you really start to create winning conditions where you're able to accelerate some of the plans that ZeroAvia has towards entry into service.
Thank you. So Derk, you've already have an agreement in the hybrid electric space as well. So obviously we have four technologies really here that we're kind of looking at. All electric, hybrid electric, hydrogen electric, and hydrogen combustion are all in the mix of sustainability somewhere, and sustainable aviation fuel. How do you approach that as Air France KLM? I mean, are you trying to get the same level of understanding across all of these technology options, or are you having to make bets as to which you think are going to be the most important to your customer base? And a secondary question, sorry about this, can you do that through working with the OEMs, or do you need to do your own demonstration program? Do you need to actually get your own people, their hands inside fuel cells, learning how to do this?
Sure. So need to answer your first question. If I think about the gravity of the challenge that we're facing, then you already have my answer. We have to do so many things and so many changes in our industry that I don't believe that one single technology is going to answer all of it. There's so many different use cases, whether it's replacing aircraft or lines that we have today as Air France KLM, smaller lines that we're not even doing, or competing with rail transport that's just completely congested. So you need some alternative. So I think in the market there's so many demand for different solutions that even from a technology perspective, it's difficult for me to say which one is it. So our strategy so far is really to learn as much as we can as a company, engage in different initiatives, but also support and really push that drive forward. And I think ZeroAvia is a perfect example, and I know that we've been having quite some engagement with them as well to really see, okay, how can we contribute to change that while also learning for ourselves. So I think that's kind of the exchange that we're trying to set up from our perspective. And then what was your second question again, Graham?
It was whether or not you do that just through working with the OEMs, or whether you have to have your own internal technology program so that you can actually get your own workforce up to speed on some of these very different technologies.
Yeah, so in that way, I see an OEM like ZeroAvia very much like existing OEMs as well. That you try to partner up as soon as they're a serious company and they know what they're talking about. So you try to partner up as soon as we can, really early in the process, to contribute from an airline perspective, from a maintenance perspective as well, because that's often an angle that you cannot that is overlooked. So I think it's very good that we do that we look at that within the industry together, but then also drive that out going forward. So it's not that we will ever become an OEM ourselves. We're not looking into finding to produce our own aircraft, but we do believe that the earlier in the development process we are involved, the better we can help to create, let's say, solutions that really fit both the MRO world and the operator world.
Okay, thank you, Richard. So we're beginning this hydroelectric journey using automotive or vehicle technology and adapting it to aerospace. And as we're already seeing on the electric propulsion side, as soon as you put aerospace engineers to work on a piece of equipment, vehicle equipment, it changes rapidly. You see big deltas in performance when aerospace engineering is applied. What does that mean for PowerCell? What are you learning or facing as you approach a different market with different requirements? How much of what you do today, you said you've got industrialized components, and you presumably have a testing regime, you have everything. When you go into aerospace, aviation, what do you have to change? And do you have to really look at the whole life cycle of a fuel cell differently when it's an airplane application?
Yes, to a large extent. But I mean, at the moment, the technology is emerging. The requirements are kind of evolving, and we see that the synergy is fairly good with our different segments. But we're now approaching aviation in a different way, where we say that aviation is now leading. It is, as I said before, spearheading and driving requirements forward. And then for us, it's a really, really brilliant arena to push technology. But I mean, Carl, you better can I think quantify what is the difference and how is aviation now challenging us?
Yeah, I mean, if you look into aviation vis-a-vis, I mean, automotive, I've done 20 years of automotive before 6 years of this. What we are seeing is you have a much more tightened requirement set from an aviation perspective. In a vehicle, you can't decide if the sold vehicle is going to end up in Siberia or California, more or less. It can have a very, very different regime. But here in aviation, it's more specific requirements, but they're quite honed, and that gives us an opportunity to make it more bespoke towards aviation, because you can. Some things are more extreme, some things are less. It's more controllable environment, controllable use case, which essentially that's sort of the bigger part. And then of course, weight. Real estate is always expensive, regardless of what you're doing. And then in aviation, weight is sort of the big thing. So solutions where material choices can change, but from a basic functionality, it stays the same.
And to kind of be a bit more specific, when we look at the next generation, because we pride ourselves to be, I think, one of the best in the industry at the moment, having really good performance to weight ratio. But still, with the next generation, we are pushing for higher temperature, higher current, higher voltage, lower weight, etc. Because that is the requirement that is going to make it commercially viable for aviation. But that's the same for any other segment that we're approaching. But then materials will be different, etc. So in one way, aviation is, I think that what Carl is pointing out, in one way, aviation is a bit simpler. But you have less tolerances for failure. So you need to be very safe. You need to have a good redundancy. You need to have durability, etc. This is also why it's so important to be active here. So for us, this is truly a driving technology at the moment.
Yeah, I'd like to jump on this point because for me, based on what I have seen in the last 10 years, when I jumped from traditional to the electrification of aviation world, you try to ask questions to all four of us and to get an answer. Now, for example, which is the part of your system which is not mature enough to enter to certification? Or what is the difference between automotive and aerospace requirement? Are you able to certify against aerospace requirement? not a single person of us can answer alone. And like a CEO of Rolls-Royce told 2 years ago, I cannot forget this sentence, in this world, nobody can do it alone. That's why explaining how ZeroAvia approach the product development is also telling we need collaboration. We need to ask the right question to ourselves or to our partners. It's not about I believe this is the system will work. I believe these are the requirements, but which requirements do you need to know? Tell me what do you expect to have from me so that I can target as soon as possible the pain points from your point of view, from supplier point of view, from maintenance, from service, from airliners, for example. Only working together we can win, not against each other, and not in a total competitive world, but in a collaborative mode. The market does not exist yet. We are creating it ourselves, and ZeroAvia has the spirit of collaboration between supplier, airliners, and maintenance organization, which is supporting the idea to discover the question, to ask the question very, very quickly, and then to answer them, to tackle them.
So can I go back to you, Gabriele? We're getting a lot of questions. A lot of the questions that are in the Q&A are about infrastructure. Now you are, I assume, kind of developing your infrastructure as you develop the airplane. You're developing how you refuel the airplane. You're developing how you generate, store, distribute the hydrogen. How important is a piece of what you're doing is that?
First point, we will speak about infrastructure in the next panel, where there will be the right expert to answer, which is a anchor for the next group. But one important part from my side, we are producing our hydrogen that we use for the whole ground test campaign and for the next incoming flights here in Campbell in the UK, all made by ZeroAvia, thanks to UK support, UK funded support. And it's not enough. We are testing more than what we can produce. Sometimes we, oh, I don't have the echo anymore, very good. Sometimes we need to wait a couple of days in order to produce enough hydrogen for our own testing and for our own ground movement of the aircraft or flights. With the flight of an aircraft like that, and by just defining how much hydrogen I need to complete a mission for this type of aircraft and demonstrating that the technology will be ready to enter into the market according to the time schedule we are suggesting, we give a demonstration that is not just an idea anymore, but it's a reality, that the infrastructure can work. We are demonstrating it to ourselves. We are producing it for ourselves to make an example. We don't want to be only an example and then to finish the story and become a book, but we need to move the world to understand this is possible. We are realizing it. If you imagine, when we take the aircraft out of the hangar, it stops in front of the door. Then we have our truck coming from the other side of the hangar, putting the hydrogen we have produced the day before into our aircraft, and then we go to ground testing and flight testing. It's not magical. It's just real. We need to scale it up.
So, Elio, when you talk to your customers, what are the, as they begin to tackle sustainability, when they begin to look at hydrogen, what are the key questions that you are being asked to answer with your customers when it comes to hydrogen as an option?
So, definitely our discussion with customers includes hydrogen and includes all other technologies. I think infrastructure, as you point out, is a question on everybody's mind. And part of the answer is what we've heard several times in this discussion today, really the aspect of it takes a village. You really need industry, academia, supply base, OEM, government, all to come together. If we're going to shift this industry. So infrastructure is a key point, but what we've heard back from our customer base, and I think we heard it earlier in the discussion that was had with American Airlines, there is a true commitment from our customer base to want to see the realization and a roadmap towards zero emissions. So each customer is at a different part of its own roadmap at a different step, but unanimously, we're hearing this across the board. Also, I think there's a realization of, a stepped approach in the industry. I think from what the industry has seen over its lifetime, you need to have the long view, the medium view, the short view to be able to get there. So there's, and we heard Derk kind of talk to that a little bit. Everybody's edging their bets, and in some way, it's probably wise to do that, because the different technologies and the different applications will probably come to market over a phased calendar time. So making sure that we're able to continue to support our industry today, and that we're able to create the opportunity for the new technologies to get phased in, matured, scaled, and adapted, I think is all part of that key success that unanimously we hear through our customer base.
So Richard and Carl, this is something there's another question about this. It's something I hear and fear a lot in aviation, is there's always a better idea just around the corner. So we are using low temperature PEM fuel cells. It's the most mature technology. We're already talking about high temperature PEM. We have solid oxide. Everybody says, okay, it's okay, but it's not great. Here's the next thing. We've seen that with batteries. We've seen it with lots and lots of things in aviation and like that. How do you feel about the runway you have, the technology you're starting with? Do you have the ability with the technology base that you have a really deep understanding of to go some distance into where aerospace wants it to go? Or are you also going to have to be looking at these other approaches to be ready for when they need to be done?
Well, I think that when we align our present plan and technology roadmap with the roadmap from ZeroAvia and the ambition to scale up size and distance in operation, I think it is fairly well aligned. The PEM fuel cell, and as you pointed out, going to higher temperature is going to be really, really important. But we see that the efficiency that we can create and scaling down weight is going to create enough value for what we know today. With that said, I hope that we will see progress that goes beyond what we see in technology roadmap today, because Derk pointed it out. We need to have many more technologies and solutions to be able to manage this. So we will embrace if something pops up that is even better. But with what we have and what we see in the roadmap, I think that we are fairly satisfied, and I think ZeroAvia can also either confirm or challenge that. But we have a rather good approach to this.
Gabriele, do you feel comfortable with the technology path that lies ahead that you can draw on?
I can officially not say I am happy with any supplier, so that they deliver. I agree very much with Richard, and yes, for sure. What you say is that there is a race to find the best new technology. I think this is a race which is run very often when there is no demonstration of capability. And what we want to do is to take one point, to take one technology, to bring it on an aircraft, to test it, to verify and understand why this is good or why it's not good, and what can be improved. If we put ourselves as a very good engineer in front of a book and we start making trades, we can stay there for all our life. I will go on pension and I will make a diploma thesis on trades. I need trades, but I need fast demonstration that the direction we're taking is right.
Yeah, if I can.
Yep.
Yeah, because what Gabriele points out and what ZeroAvia is showing every day is that, I mean, good technology or the best technology is not what is going to accelerate this business. It is the buildup of application knowledge, bringing actual field testing the data back to us and everybody in the value chain, then improving the technology. So right now I'm focusing on optimized good enough, not the best technology, because best technology, then we can sit here 5 years from now and still talk about what can be done next year. So optimize good enough and then out there testing and go back and reiterate.
So Elio, there's a question here that I was actually going to ask you earlier. As an OEM with an aircraft at the top end of what we're kind of looking at for fuel cells at the moment, you know, that 70 to 90 seat ranges. There aren't many. I mean, Airbus yesterday talked fuel cell for 100 seats. You're at the top end at the moment. I mean, are you also having to, at the same time, in parallel, pursue the hydrogen combustion route? Do you have to be at a point where you can say that's one of other of those are right, or do you feel that you're in the point where fuel cells, because of their efficiency and everything like that, are really the best path to go?
I don't think anybody is ready to down select or discontinue any technology at this point. There's too much discovery that needs to be carried out, and the maturity of the application to be defined. What I can say is that the work that we have done with ZeroAvia has already given us the confidence that and I'll bring up the word infrastructure, but this time within the aircraft, we've been able to successfully map out and allocate the real estate required to host all of the additional features and equipment required by a hydrogen fuel cell technology. So this is a huge team success that we've been able to celebrate together. Being able to adapt today's aircraft and demonstrating that you're able to position the hydrogen fuel tank, you're able to position the fuel cell, you're able to accommodate the new propulsive technologies that are required. Being able to walk away from that at this early stage with the confidence to continue to mature these details is already a huge win. So, is it time to decide left or right? I don't think so. But if we talk about the work that we are doing with ZeroAvia, being able to build early confidence in the adaptability of this technology onto existing aircraft is a huge step. Let's remember, when these aircraft were designed, the current fleets that are out there, they were not, being able to carry hydrogen and hydrogen fuel cells was not a design point. So one of the first steps is to just understand, can we do that? Can we put this technology onto existing platforms? And what we're seeing is good indication that the shapes, the real estate, the volumes available do allow that to happen. So that's a big early win. And what it does is it keeps, definitely keeps the fuel cell technology in the game in a strong way.
So we have to wrap up here, but I wanted to go back to Derk just for one last question. The unusual characteristic of where we are in aerospace at the moment is it's the startups that are making the running, not the traditional aerospace companies. Traditional aerospace companies are getting involved. What does that mean for a traditional, really, really core traditional aerospace industry like MRO, AFI, KLM, E&M, to be working with a startup? Is that actually an energizing, is it a good thing that you're getting exposed to?
Who's the question for, Graham? Is that for me?
For Derk, yeah.
Sure. So obviously it's very energizing, and it's great to work with companies like ZeroAvia personally and for our organization. So I think for two reasons. So first of all, we're learning a lot about what will be the technologies of tomorrow. But at the same time and in parallel was with the discussion we had for the past 10-15 minutes, we're also rethinking how do you innovate in an industry that's extremely safety driven, which we're not abandoning at all, I think. But within those safety boundaries, how can we be more innovative? How can we go to market faster? How can we test and trial much faster? And I mean, we've had a good track record of the past 10-20 years to work with universities and a lot of startups in, let's say, applicable technology. So we are leveraging how do we as a big company with a lot of different divisions and also some politics and all the standard cliches you have of big corporates, how can we work better together with startups in general, but I think in aviation more specifically, and I'm really looking forward to that. And personally, I think it's really a nice, I'd say that challenge that really creates a lot of energy within our company.
So I just wanted to close on that because that's my personal view. I've been writing about aviation for more than 40 years. I was an engineer, recovering engineer, many, many decades ago. And I find that the excitement and the challenge that the startups have injected into aerospace is extraordinary, but also the way that they're evolving to address the safety issues and not just continuing to drive down the fail fast, move on, but fail fast, learn, come back safer type thing. So folks, I think I need to wrap up there, but I really wanted to thank you all for a tremendous discussion. So Gabriele, Elio, Derk, Richard, Carl, thank you very much for joining us.
Thank you.
Pleasure.
Thanks a lot.
Thank you, Graham. It's really good panel. I think a lot to unpack there. I particularly enjoyed the kind of dating app reference language when Elio said we're not quite ready to swipe right or swipe left on corporate technologies just yet. But no, brilliant stuff. We're gonna take a quick break for 5 minutes.